In this video, we're going to be talking about how to resolve fractions into partial fractions from type 1 to type 4. Type 1 to type 3 is all about proper fractions, while type 4 is improper fraction. Now, how do we determine if a fraction is a proper fraction? A fraction is a proper fraction if the degree of the numerator is less than the degree of the denominator. Now, let's consider these two fractions. If you pay attention to them carefully, you notice that they are all proper fractions simply because the degree of the numerators are all less than the degree of the denominators. Now, if we have a situation like this, how are we going to resolve into partial fractions? Let's get started. Now, for this right here, if we try to set this one into partial fractions, of course, we will end up getting two separate fractions. And for the first one, we are going to have a constant numerator simply because we have a linear factor right here. So we're going to have x minus 1 here. Then for the second one, we also have a linear factor. Therefore, the numerator of the second fraction will be a constant, then divided by x plus 2. So this is how to set this into partial fraction. And solving this one will take a couple of time. If you are looking for how to solve problems like this or solving for both A and B, I have a video on that in the description down below, so you can just check them out. Then the next one, let's consider this one. And you notice that for this right here, we have a quadratic expression on the denominator side. Before we can express this into partial fractions, we have to first factorize the denominator before we can do that. So in factoring this one, of course, the numerator will still remain the same. Then all divided by, this is factorable quadratic expression. And if we factorize, we are going to have x plus 2 as one of the factors. Then the next one is going to be x plus 3. And this is what we have for this whole fraction. And to set this one into partial fractions, we are going to have a constant numerator for the first factor, all divided by x plus 2. Then plus another constant numerator for the second factor, which is x plus 3. And this is how to set this into partial fractions. Now let's consider type 2. Now here we are in type 2, where the denominator is quadratic irreducible factor, or a quadratic expression that is not factorable. If you try to factorize this one, you will end up getting complex factors, and we are not interested in complex factors. So this is quadratic irreducible factor. And notice that this is also proper fraction simply because the degree of the numerator right here is less than the degree of the denominator. So to factorize this right here, we are going to have a linear numerator simply because the degree of the numerator on the partial fraction must be 1 less than the degree of the denominator. So this will be a times x then plus b, all divided by the quadratic irreducible factor, which is x squared plus 1. So this is how to set this fraction into partial fraction. The next one is this example right here. Feel free to pause the video and give it a try first. And let's get right into it. And you notice that the first factor right here is linear. Therefore, it will have a constant numerator divided by x plus 1. Then plus, now this factor right here is quadratic irreducible factor. Therefore, if the degree is 2, then it means that we have to get a linear factor. So the numerator is going to be bx plus c, then all divided by x squared plus 3. This is type 2. Let's move on to type 3. Again, here we are in type 3 where we have a repeated factor. You notice that for this factor right here, it is multiplying itself twice. Okay, so to express this in partial fraction, this is going to be the first factor, which is linear. Of course, whenever it is linear, we will have a constant numerator. So we have x plus 2 right here, then plus, this is a repeated factor, which will be b, then divided by x minus 1. Then the next one has to be a constant once again, divided by the exact same thing, this time to the power 2. So you notice that when the factor is a repeated factor, then we build the powers from smallest to biggest, starting from 1. Cool. So let's consider this example right here. How can we express this in partial fractions? To do this, you notice that we have inside the parentheses is a linear, then it is multiplying itself 3 times. So to express this in partial fraction, we're going to have the first one to be a constant numerator, then divided by x plus 1. Then the next one is also having a constant numerator, this time x plus 1 all to the second power. We are building the powers, okay? Then plus c divided by x plus 1 all to the third power. So assuming that if this power right here was 4, we would have continued building the powers. So the next one would have been plus d divided by x plus 1 to the fourth power. So that is it for type 3. Now here we are in type 4. For this particular type, you notice that the degree on the numerator is equal to the degree of the denominator. Now one key thing you need to pay attention to is that if the degree of the numerator is greater than the degree of the denominator, then that fraction is an improper fraction. And to resolve this into partial fractions, we have to first divide the numerator by the denominator to obtain a quotient and a proper fraction. So quickly, if you try to divide the numerator by the denominator, we will end up getting a quotient of positive 1, then plus a proper fraction, which is gonna be 3x minus 1, then all divided by the factors of this quadratic expression, which is x minus 1 multiplying x minus 2. And that is it. So if you are looking at how we can divide this one by this, I have done a video on that in the description down below, so you can go there and then figure out how we can divide this by this right here. So guys, this is a quick review of how you can set partial fractions when you are given a fraction. So that is it for today. I believe you found the video useful. Make sure you give me a thumbs up, subscribe to my channel for more. Go to the description of this video. You can see a couple of videos. You can check them out. See you again on the next video. Have a nice day. Take care. Bye bye.